Involvement Coordinator for the Nuclear Metals Superfund site, and I'm also the Community Involvement Coordinator for the WR Gray site. And tonight I want to introduce the site team, and I think I'll just have them introduce themselves. We have we also have Gary Waldeck. And Bruce Thompson from.
Bruce Thompson, I'm with the Maximus. We're the general contractor doing all the work.
So if we could move on to the agenda. Tonight's meeting is focusing on the environmental restoration of the nuclear metal site. And I just want to quickly walk you through what the topics that will be covered tonight. Bruce will be doing a brief history covering the Superfund history at the site, followed by a discussion on the investigation and removal actions that have happened at the site to date. Some of you may be more familiar than others. So Elaine will be speaking about the record of decision, which is the selected remedy for the long-term cleanup at the site. And Bruce will be talking about the what's called a non-time critical removal action for groundwater, as well as the building non-time critical removal action. Elaine will talk about the remedial design, remedial action for soil, sediment, and groundwater, and restoration and post-remedial activities at the site. And I apologize if some of that sounds like a little tech talk, but as we walk through the presentation, we will have an opportunity at the end. There'll be a 30-minute question and answer, and you're welcome to ask the site team. This is a good opportunity to get any questions or concerns out to the site team here. If you haven't signed in already, I would ask that you please sign in the back and leave an email address so we can send you future information. Also, there is a recent fact sheet that was done about what we're speaking about today, and our site team's contact information. So if you haven't picked up a packet, please go to the back room and take some of the handouts. And I'm going to turn it over now to Bruce from the Maximus.
First up is actually Elaine.
Oh, I'm sorry.
It's okay. What's that? Oh, thank you. Okay, the project area is located right off of Main Street in West Concord, just south of the Assabet River. To the north is the WR Gray site, or some of it, and then we have the water supply wells, Assabet 1A and Assabet 1A2, 1 and 2. And these are supply wells, existing supply wells that the Acton Water District manages. And we have, right now we have what we're showing a groundwater plume of VOCs and 1,4-dioxane, which is a semi-volatile organic compound. And Bruce will talk about what that is. And so we're going to be actually doing treatment. We actually started pumping, I think yesterday morning, we started it up, and we're going to do some treatability studies in order to cut this migration of contamination off, so it will not go to the wells. We're going to cut that off. The Superfund process, I'm just going to go through this really quickly because I think probably most of you know what it is, but essentially when you have a site, typically it's an uncontrolled site in the beginning, and you need to figure out what's happening at the site So you do a hazard ranking, you look at all the contaminants of concern, you look at the risks that it could pose, and then it's scored. And if it gets to a certain score, it's put on the national priorities list with state concurrence. And once that gets listed, it's eligible for federal funding. And then we start doing the investigation with the remedial investigation to determine the nature and extent of the contamination and in all media types, soil, sediment, water, air, and also just could be, just hazardous materials in and of themselves on the property. And we also do a risk assessment to determine what kind of risks that these contaminants pose or could pose. Once we've done that, we look to see what is the best way to, what kind of alternatives we would have to actually address these risks and look to clean the site up and control the site. And that's with the feasibility study. And that is where we go through all the costs of is it implementable? Is it too costly? What happens is you run through 9 criteria to determine whether an alternative is actually going to be worthwhile, feasible to do, both in terms of cost, public acceptance, state acceptance. Is it practicable, not practicable? And once we look at that, all those alternatives, EPA puts together a proposed plan of what we think that the best alternative would be, and put that in a proposed plan and send that out to public comment, usually have a meeting, and we welcome comments from the public, and we go through those comments, respond to the comments, and then we put out our record of decision, which is actually the document that tells us what we've selected as a remedy, and that's the cleanup plan that we have to do. Something can come along and change in midstream, or where we would have to address something that we didn't know about before or whatever, and we would have to either amend the record of decision, or we would do what something's called an ESD, explanation of significant difference, which is it has to be documented, going out for public comment again. So we try to keep the public involved as much as we can. Once the record of decision has been issued, we then start with our remedial design to sort of actually get to the nitty-gritty of how we're going to actually carry this out. Detailed plans and specifications. And then this particular site, it's what we call a potential responsible party lead site, where some of the PRPs are actually performing the work. We do have a settlement with federal agencies. There's 2 federal agencies, the Department of Energy and Department of Defense, that are also responsible parties. And then we have 2 companies that are responsible parties, and who are actually performing the work through DeMaximus. And DeMaximus has been on the site, I believe, since around 2003 or so. And we get this work done by agreement through either administrative order on consent or a consent decree. Administrative is not in federal court, but a consent decree does go through federal court. There's also a chance with the consent decree to have public comment on that too. So, and then once the remedial design is complete, we go forward with the actual construction of the project. Sometimes it takes a long time. A lot of times it's in working out the documents, the legal documents, that takes a while to do, because you need to have financial assurance, make sure it's being done right. And also, the other type of situation would be if there's no responsible party that we can find. They're either bankrupt, gone, or their EPA has just sued them and they're not paying. So EPA will fund that site. It's called a fund lead site, and where EPA will get contractors to actually do the work. That's not the case here. Once we have the construction complete, we go into long-term monitoring to make sure that we are still protective and that the remedy is working as it was designed and constructed. And there's operation and maintenance that is done, particularly with treatment systems. And long-term monitoring also goes toward restoration projects where we have to restore a wetland that has to be monitored to make sure it is functioning as designed. And then we have to implement institutional controls, which is restrictions on groundwater use, land use, soil use, signage, and that will happen on this site. And we look to see what kind of future use we're going to have at the site, and it's actually going to be for residential. So the cleanup levels are for residential land use, which is the most stringent type of cleanup that we have. And this is another view of the site, a little closer up. These are the former buildings that were taken down during the building non-time critical removal action that took approximately 5 years to do, and Bruce is going to be going through that. Bruce?
I think I'm just going to be loud.
Okay.
Everybody hear me if I don't use the mic? So far, so good?
I'm sorry to interrupt. The cable is trying to record, and they need you to use the mic in order to, the cable station. Sorry about that.
That's fine. So in 1972, the employees bought out the company, and they really started making these, what in the military you'd call silver bullet. It's a depleted uranium penetrator. This site, they made 120 millimeter penetrators for the tanks, 40 millimeter for the A-10, 20 millimeter in the Navy. And so there's the penetrator in there. That's about 10 pounds of depleted uranium. That's the principal problem that we have at the site. Solvents were used, and we're going to talk about why we have solvents in groundwater for degreasing. Late 90s, they changed their name. They called themselves Starmet. They also lost the federal contract for making depleted uranium penetrators, and they started making other stuff there. So they made beryllium products and a variety of other things. They did a little cleanup at the site. I'll show you some pictures later on. They lost basically their license to manufacture anything with radionuclides, and then they went to possess only. The company also had a separate facility down in South Carolina, and they brought up thousands of drums of uranium tetrafluoride and stored them in the building, which when I got involved in 2003, that was my first view inside, and it was actually the scariest circus site I had been in at that point. Here's some of the silver bullets, the penetrators that were being removed. So with Army funding through Mass DEP, $7-8 million later, they got thousands of drums and hundreds of tons of depleted uranium out of the facility. That's what we would call a good start. In November, they left and basically handed me and John Hunt right there, for my company, the keys to the building and said, we're done, goodbye. And there was half full coffee cups, and we started our work in the buildings. Let me just talk a little bit about the Superfund or the EPA timeline. So the site had been regulated and was being studied under the Massachusetts Contingency Plan, under the Mass DEP's purview, originally because they found significant concentrations of solvents in one of their on-site wells. It went through the process, it got requested through EPA and got listed on the national priorities list. That's the 1,300 most contaminated places in the country. EPA came right in and did some removal actions on site. Oops, sorry about that. This is what was called an old landfill area. They had buried some equipment that came out of MIT. That's about a 4 acres sphagnum bog that's adjacent to it. They had a pit, and the holding basin comes up a lot. So in the process of making a depleted uranium penetrator, they would jacket a billet of uranium and copper and extrude it through a 1,300-ton press to make a nice cylinder of it. They would burn the copper off with a mixture of hydrofluoric and nitric acids and kind of neutralize that. And that sludge got dumped out in this pit out back that we call the holding basin. Very quickly, EPA came in and put a cover over that to help stop leaching of uranium into groundwater. So that was what we called a time-critical removal action. My company and I got involved in 2003, helping to negotiate from the settling party side the order that led to what we call the remedial investigation and feasibility study. That's the process of delineating the nature and extent of contamination, assessing the risks that it poses, and then going through a process of figuring out what can you do about it and how much it will cost. So we started that and really started doing investigations at the site in 2004 after 4 3-inch ring binders of work plans had been studied and approved. NMI or Starmet had a couple of little fires, got more attention from the Concord Fire Department and others. EPA came in and did another removal action and took out more chemicals and flammables from inside the building, and also made the decision that the buildings pose a direct risk to human health and the environment, and they need to go away. So that led to what's called an action memorandum, which is how EPA formally authorizes to go do something at a site. And several years later, we had an administrative order, basically a direction to people, including the federal government, the Department of Energy and Department of Defense, to pony up the money. This was a $70 million project to get rid of the buildings. We started work the day that Starmet left and started securing the site, and I'll talk a little bit more about that in a little while. Along the way, we also finished the RIFS. The studies at this site ended up costing about $16 million because it's a big site, and I'll show you some reasons why. We also realized, even while EPA was going to make a decision about what to do about this site, that the standards had been changing for some of the groundwater contamination, and there was more work to be done. So we went to EPA and DEP and basically started figuring out how to go do more studies, really on the fly, and I'll talk about those in a minute. EPA issued the Record of Decision, which is the formal document that says what has to happen at this property, in September of 2015. Also realizing that there's a problem with this particular contaminant, and we were seeing concentrations go up in the Acton municipal wells, EPA put a second piece in, another action memo, to do something faster, and that's really what we're here to talk about tonight. Last fall, we finished up the building work, and we put a cover over all the slabs to hold it there until we're done. EPA followed up and issued letters to the Army, the Department of Energy, my clients, saying, come back to the table and start negotiations on the $120 to $150 million more work to be done at this site. And I got out of order here, but in July, we also got the funding to do the work that we're in the midst of right now. So a little bit of show and tell. The building work. So the rationale here is really prevent releases to the environment. The royal we, the EPA, DEP, citizens groups we've been working with in Concord over the years, my clients, everybody said, if these buildings catch fire, we have a really much bigger problem. So let's see what we can do to prevent releases, prevent direct contact, and there's contamination underneath the buildings. So the buildings have to go away in order to go dig up that contamination. So this is a necessary step towards the long-term solution. So, as I said, they handed us the keys, they went away, we started going through the building, and basically it took a couple of years to empty out all the building contents. And I'll show you some pictures and you'll start to see why. Then we went through and vacuumed. After we emptied the buildings, we vacuumed the interior of them so that when we started demolishing them, we wouldn't have any airborne exposures or releases of depleted uranium, beryllium, asbestos, and so forth. We put a cover on it, and we took all the debris. Well, the vast majority went out to a giant landfill out in Idaho. And right now, we're still doing some controls at the site until the long-term remedy kicks up. So when we walked in, the interior of the main production building looked like this. That's a lathe. Depleted uranium dust is what we call pyrophoric. It means it spontaneously ignites on exposure to air. And everybody in the building said, hey, you know what? You pull up these trays, you're going to have fires. We didn't have any, but we went very carefully. You can just see the vast amounts of debris. And this is a several-acre building, two-story high bay, that was emptied before we took the buildings down. These are the actual vacuum furnaces where they melted depleted uranium and then cast it. You can imagine those were significantly contaminated. This is the area they called Pickling. This is where they use the acids to burn the copper jackets off the penetrators in these trays. You can kind of see the yellow there. That's uranium oxide on the floor. Starmet pretty much worked in like lab coats. You can see what our team worked in: full suits, powered air purifying respirators. These buildings were not air conditioned nor that effectively heated. So some of the guys in the back room there would lose 5 pounds in a 4-hour shift inside the building just in sweat weight. But that's how we work to be safe and protective of our staff. All this ductwork and ventilation systems on the building was impacted with either depleted uranium dust, beryllium dust, asbestos, lead. So we went through a very careful process of taking it all down, basically shrink wrapping it, cleaning it, removing it, before we started taking down the buildings. So in the next picture, this building's already gone. These ones are in process. So here's partway done. This has a plastic cover on it like you'd put on a landfill. And you can see the machines over here taking it apart. That was all done last fall. So this is as the property sits right now. It will remain like that until we get into doing the actual remedial design and remedial action. At which point, after more design and some more work, this stuff will get peeled up, the concrete slabs will come up, the contaminated soil underneath the slabs will come up, and that will also go to a landfill in Idaho. Over the course of getting rid of this, you know, whether you work in tons or cubic yards or pounds, you know, think of it as 912 truckloads of stuff were safely transported off this property, went on trains, and then by train out to Idaho. The right side, and I'm certainly not going to go through it, but that's all kind of the non-building and kind of bulk stuff that went out. And it was going through the building very carefully and saying, oh, all this caustic stuff really can't be next to the acidic stuff because it will react, and segregating things, neutralizing it, and take it off-site. We finished the work about $15 million under budget, which is probably a rarity in a Superfund site, but that's really a testament to the folks that were out there working and getting this stuff done. So that part's done until we get to the remedial design and remedial action. Let me just talk a little bit about some of the studies that I earlier mentioned. You know, we went through $16 million in work. So here's the boundary of the roughly 46-acre site. And this is just a synthesis of basically all the sampling points. Many of these have multiple depths at each point. But just for kind of rough justice, this is about a sample about every quarter acre of soil. And then there's monitoring wells, there's sediment, surface water, a wide variety of data. In here in the holding basin, we're drilling down 90, 95 feet through the soil to get soil data. Very comprehensive study. One thing that's important is that, I mentioned our key issue here is depleted uranium. Depleted uranium is just that. There's less U-235, the fissionable component, so it's actually a little less radioactive than natural uranium. But uranium is a heavy metal, like lead. It's a poison to kidneys and so forth. So we set up remediation levels to track as we were doing our studies. And let's just talk about soil in particular. The worst soil is right around the buildings. You can see the buildings themselves have no data because when we were doing our work, Starmet was still there. We couldn't get in and drill through. We've now drilled through the slab in places. But the important thing from our point of view and why you see no dots, except for we did some here, but like up here, this is Thoreau Hills residential neighborhood. And we did not go sample in people's backyards because we had a very clear concentration gradient from highly impacted to background as we got up towards the property line. And uranium's a naturally occurring metal. The background levels are a little over 1 part per million. And we were down to background by the time we got up to the fence, and that's why we didn't end up going up and sampling in people's backyard for soil. Our cleanup level is only about 2 times the background level, and that's the safe level as we got to through EPA's work. I'm going to talk about groundwater in much more detail, starting now. So here's sorry, and tonight you don't really see it, but here's the footprint of the buildings, and here's the holding basin. And what's deemed to be the safe level of uranium in drinking water is 30 parts per billion. That's the little UG per L. So 30 parts per billion. And the red line is the extent of depleted uranium in groundwater that exceeds that. So out here, as we get out towards Route 62, we're not exceeding the drinking water limit. One thing that we did, well, we didn't do, our key subcontractor, Geosyntec, who's located here in Acton, we did some modeling of how this plume would evolve over time. And basically at the end of that, we did, it's a model, it's not perfect, but the upshot is over 100 years of not doing anything, this plume would slowly continue to migrate and get to the property line. And that was justification to come up with a remedy to keep it from doing that, and then also to clean up the portion that's in the groundwater. So when we talk about the remedy, you'll see a little bit more about that. In bedrock, we had a different problem. The depleted uranium was clearly from disposal in that holding basin. We have a bunch of bedrock wells, which basically think of them as starting in the solid rock at this site, 60 to 95 feet below the soil level is where you hit the bedrock. And we have a isotopically natural, meaning it's like all the other uranium in the world, but it's over the same cleanup level, and we have a rough plume there, and we are up to about a maximum of about 200 parts per billion. It's incredibly stable, meaning this plume is not moving and the concentrations aren't really changing. We don't have an answer for how it came to be, whether it's something directly related to the site or not, but we have a clear exceedance of a drinking water limit. That's the bullseye's right in the middle of this Superfund site. So as part of the remedy, we're going to have to address the depleted uranium plume in groundwater, or I'm sorry, the isotopically natural uranium plume in groundwater. And now I think I better let Elaine talk about the rod.
So this is the remedy, the cleanup for the entire site, where we want to make sure that we're going to get to our cleanup levels, and so we can be protective of human health and the environment. So what we've done is there's basically 2 major components, the soil and sediment, and then the groundwater. We also knew at the time, as Bruce had mentioned, that just before the ROD was issued, we knew that the 1,4-dioxane, the levels were going down in terms of risk posed. In other words, we found that that the concentrations at which the contaminant would pose a risk would keep getting lower and lower and lower. So, and that's why we had noticed that the plume actually extended further because of the concentration levels. So what we did was we added another non-time critical removal action to the ROD, basically saying we're going to try to address that as soon as possible, not wait until we've got the whole design of the entire cleanup done. We're going to try to do this right now. And that's what we're doing now. Bruce will talk about that. That's really kind of the focus of our meeting tonight is what we're doing right now, this non-time critical removal action for the groundwater. So for the cleanup levels, for the key contaminants of concern, we call them contaminants of concern. For the soil, it's polyaromatic hydrocarbons, PCBs, polychlorinated biphenyls, arsenic, uranium, and thorium. And as you can see, we have our cleanup numbers. These are the cleanup numbers based on risk posed by these contaminants. For the sediment that we have on site, which would be in the wetlands and the sphagnum bog, we have ecologically risk-based cleanup numbers for PCBs, copper, lead, and mercury. PCBs is typically 1 part per million, 1 milligram per kilogram equals one part per million as a cleanup number for PCBs. For groundwater, we have some metals along with the VOCs that Bruce had mentioned, typically 1,1,1 trichloroethene and tetrachloroethylene. Vinyl chloride, which is a breakdown product of tetrachloroethene. Another actually very, very toxic solvent, which is not really used that much in the industry today anymore, as well as uranium and obviously the 1,4-dioxane. So for the soil and sediment remedy, we're going to actually excavate and remove off-site about 82,000 cubic yards of soil and sediment. And that will take a lot of that material is under the buildings. There's a figure that we'll show after this that will show you exactly where these areas are on the site. We also have the holding basin, which is a separate sort of unit that we're going to be basically doing a hydraulic containment. So we're going to be putting an impermeable wall around the entire holding basin all the way down to bedrock, and then putting an impermeable cap on top of it, and then put more backfill material on top of that to grade. And that will basically not allow anything in that holding basin to migrate off-site, particularly the groundwater. Now, what we're going to be doing there too is we do in-situ or treatment right inside the holding basin. We're going to be adding this chemical called apatite. It's a high phosphate material made of, I guess, char bones, powdered char fish called char bones. There are other types of phosphates that we can use as well. And that will basically bring the uranium to a metal type, stable metal. And then we're going to be restoring the site. That includes wetland work as well. The soil and sediment remedy, these are the areas where we're going to be actually doing soil and sediment removal, the colored areas. And these are just like the estimated depth of excavation. And when we do the cleanup, we're going to be doing confirmatory sampling to make sure that we are hitting our cleanup levels, and that that's a really important part of this, is to make sure that we've actually cleaned up to what we're supposed to clean up to. This is a figure of the holding basin, a plan view, and this will be the impermeable barrier around it. This is a cross-section view, as if you're looking at it sideways. So this barrier wall will go all the way around it. Then we'll do the in-situ treatment, put it on the cap. This is the groundwater table, and this is the plume that's emanating from that holding basin for DU, and that's going to be treated in-situ as well with the same material, apatite, or something like apatite. The groundwater, we're going to be doing the in-situ treatment, like I just mentioned, for the overburden and bedrock depleted uranium and uranium plumes. We're going to be actually doing ex-situ treatment from extracted groundwater from bedrock and overburden areas where there's groundwater contamination. And we're going to start on that with the groundwater removal action that we're doing now. And as we go on to finish up the remedy, we're going to need to do a five-year review. What happens is once you've started the remedy, you need to look at the site. It's a statutory requirement that we have to look at this. EP has to look at the site every 5 years to determine whether or not it's still protective of human health and the environment. We also are going to be implementing the institutional controls that I spoke about earlier regarding prohibition of groundwater use until it meets the cleanup levels for the contaminants. And also, like for the holding pond, we don't want anybody to be digging into that. So there'll be a land use restriction for that. And then obviously monitoring, groundwater monitoring wells to ensure that we are where we are with our groundwater treatment. The entire remedy for the groundwater is about $20 million. Okay. At the time of the ROD, these were the groundwater plumes, the VOCs and 1,4-dioxane plumes. This is the site boundary right here. This is your natural bedrock, natural uranium bedrock plume. This is your overburden depleted uranium plume from the holding basin. So this is kind of what we saw at the time of the ROD. And as you know, the concentrations for 1,4-dioxane were going down in terms of risk that they posed. So which is why we decided to do this more timely action for groundwater that we're going to be doing now. Okay, and Bruce?
Sure. So we've talked about the rationale for the groundwater NTCRA a couple of times. In short summary, we saw the concentrations getting higher at Assabet 1A in particular, and realized we needed to do something sooner rather than later to not more significantly impact the public water supply. So the general scope here was to design and construct a system. It's a pumping well and a building that's sitting over on Knox Trail right now to treat that water. And right now we did a temporary system because it allowed us to start the pumping process sooner rather than later. In parallel, we're starting what we call a treatability study, which is simply trying to look at the best means to treat the extracted water over the long term. It's getting discharged to the river, and then we're going to operate and maintain that system and monitor what's happening in the groundwater. Well, the real reason we're doing this is this chemical called 1,4-dioxane. It's a semi-volatile, which just means it doesn't evaporate very well. You can't blow air through it or bubble air through it and strip it out. It's a cyclic ether, so for the chemists in the room, here's here's your ring with your carbons, your hydrogens, and then your 2 oxygens. The biggest issue for us is what we call, in our world, an emerging contaminant. That means that 2 things. When we started this process, we weren't really sure how to measure it, nor did any of the laboratories know how to measure it. So there needed to be a process to figure out in analytical chemistry how to measure this in water. In parallel, the toxicology needed to happen. They weren't sure, as 2002, 1,4-dioxane was not a thing. We weren't looking for it at any site. We weren't aware of any toxicological properties of it. So we had to come up with methods to measure it and then also to evaluate the risks it may pose upon ingestion. This particular chemical was used as principally we see it at environmental sites where there was the solvent 1,1,1-trichloroethane. It's a common degreaser. So sites where there's this degreaser, you probably also find 1,4-dioxane in the groundwater. It's also a byproduct of ethoxylation, so it's in cosmetics, it's in face cream, it's in shampoos, basically things that have surfactants at significant concentrations. So we are also now seeing it in the effluent of municipal water treatment plants, because all your soaps and other things go into your sewers, and it doesn't get treated very well in municipal POTWs. Levels that are in cosmetics and things have started to drop off significantly since about 2005, when the FDA and cosmetic manufacturers realized they need to start getting this stuff out of consumer goods. It's miscible in water, which just means you can mix as much dioxane with water as you want. It doesn't separate like oil and vinegar. It doesn't sorb onto carbon, so it moves in groundwater very quickly. It also doesn't biodegrade very well. So all this makes it what we see in our world as being more mobile. It moves faster, and the plumes in groundwater can get longer than with some other constituents like fuel oil. If you have a fuel oil spill, it won't go very far in the water. This can go much further. Elaine mentioned how the concentrations were changing. So just a quick graphic. On the right side here, this thing that says MDL, that's method detection limit. That's the concentration in parts per billion, and then you can look over at the timeline on the left here, of what we could measure if we take a sample and send it to a laboratory. That's the lowest number that they could see. So when we started and we did our first work plan on the site, 1,4-dioxane wasn't a thing. There were no methods to look for it. Nobody cared. It didn't exist as far as we knew in the environmental community. Over time, that method detection went down, or method detection limit went down. These are kind of, think of them as the risk-based numbers. So when we first started, the Massachusetts guidance value was 50 parts per billion. It's now 0.3. EPA's values dropped from 6.1, and then as the toxicologists got a hold of this, and they looked at it and did animal studies, the concentrations that were deemed acceptable in drinking water also dropped. So for us that were out here taking samples starting in 2005, or even worse, our first ones, we could measure 50. A couple years later, the risk-based number drops down, and our data's no good. We can't tell if we have a problem. Most particular for us is our last real round of sampling at the site for the rod was in 2013, and the numbers kept creeping down. The detection limits kept creeping down. So by the time EPA was getting ready to look for a record of decision at NMI, we knew that our data, our sampling, was insufficient to bound the extent of this problem. Earlier I mentioned my clients, we went to EPA, Mass DEP, and said, we need to start doing more work as soon as we can to try to get our arms around the extent of this problem. And that's, we came in and did further work, more locations, I'll show you some figures. And that really helped set us up for where we are today in terms of understanding the extent of this problem at this site. So basically tagging into that, even before the ROD came out, we had a work plan into EPA to go do further studies. We'd had one side problem. We didn't have any money left from our RIFS budget. Our work so far at this site has all been pre-funded. we would go to our clients in the Army and DOD or DOE and say, at the start of the RFS, we need $7 million in the bank. They ponied it up. As we needed more work, we went and got more money. We had $70 million in the bank at the start of the building work because we couldn't take the chance of running out of money when you're counting on the federal government to pay for something, and we were out of budget. Mass DEP came in, had some money left over from their drum removal at the site, and allowed us to use that to jumpstart this work basically until the NTCRA order became effective last summer. So this has really been a pretty amazing cooperative effort to try to address the problem. We've been installing wells and doing a pump test. That's simply seeing how many gallons per minute do you need to pump to contain the groundwater. They're better shown on a graphic that I'll give you in a minute. We got our design done for the system we just installed in January. It was approved in March. The system's in. We flipped the switch and started pumping Tuesday of this week. So just these are, all these little tags are all monitoring wells where you see, say, 3. That's 3 different depths on this chart. The blues are down in bedrock. The golds are in overburden. So at different locations, we can have 3 different wells to sample. These are some of the wells associated with the W.R. Grace site. Virtually all of these were from NMI. Over in here, there's a mixture of wells that were installed over the history of Grace and now have been installed by our contractor. The important thing is that since the ROD, all the little green donuts are new drilling. So that's about $1 million in work, just putting holes in the ground, basically. Now, a little more complicated figure. The purple lines are ISO concentrations, lines of equal concentration, with the outside dashed line being at the cleanup level from the ROD, and then a high concentration in this little bullseye, about 40 parts per billion. So that's 2 orders of magnitude higher than the drinking water standard. The blue lines are groundwater elevation. It helps us look at what direction groundwater is flowing. Here's Assabet 1A, municipal water supply well, pumping 250, 260 gallons per minute. This is where we installed our extraction well to cut off the conveyor belt, if you will, of 1,4-dioxane that's being dragged over to Assabet 1A. The black dashed line you can think of as, we call it a capture zone. Think of it as groundwater on this side of the line gets turned, even if it's here, and gets pulled back and extracted out of our well. Groundwater on this side of the line will continue to move towards Assabet 1A and be extracted there. Obviously, where we had to put our well doesn't capture everything above 0.46 parts per billion. That's because where we could drill and put this was limited by really the geology, the best place to put the well, distance and issues, and just really trying to be protective of the Assabet well. And the important thing is also that this well does not only extract water in this direction. An extraction well like this extracts water really in 360 degrees around it. And based on work that we've done, this well extracts a lot more water in the north-south direction because there's a lot more gravel and sand, more permeable stuff in the north-south direction. So we've got, as you can see, a bunch of monitoring wells here where we just did the first round of sampling last week. We're going to be sampling them routinely. And our prediction is we're going to see concentrations really in here. They'll change slowly because the groundwater moves very slowly. Here, it'll clean up faster. And that's really our next phase over the next few months, to go out and sample those and report that data to EPA, DEP, and Acton Water District. Here's the plume. I'm sorry, with the room it doesn't show up as well. But here's the same plan view, Assabet 1A, our extraction well. And here it is in cross-section. And our well is screened, meaning the slots where the water enters the well are down at the very bottom. Here's bedrock down here. We're extracting from deep. Here's the river. So the Assabet River is not a giant boundary. It's not that deep. And the water above this line is clean. Based on the mapping we did in our sampling, the highest concentrations are down deep. And that's because the pumping here at Assabet 1A has basically been, think of it like a vacuum cleaner. It's been dragging the stuff under the river, and this is the best place to intercept it. So, as I said, that well started up on Tuesday. We have a temporary system in place where we're going to treat the water before we discharge it to the Assabet. Ideally, starting next week, we're going to start treatability study, which means we're trying out some different technologies to treat the 1,4-dioxane. It's actually difficult to treat. And we're going to go through a process to identify what's the optimum long-term system to install. Long-term is unfortunate. In groundwater treatment and environmental sites, and I know many of you, you have experience at other sites, this can be a 20-year process or more. So we need something that's going to be reliable and effective over the long term. But we have good ideas about what that is. We're going to go out through the testing process, design process, and expect to be able to jumpstart and get a system in place by the end of the year for the long term. Point for us, though, is meanwhile, we've already started cutting off that flux or the flow of 1,4-dioxane heading towards Assabet 1A to try to be protective of the municipal water supply. And I'll let Elaine talk about RDRA and next steps.
So for the long-term full remedy, we're going through the remedial design, remedial action process that I described earlier. And what we're doing is we're going to negotiate through a consent decree that will be filed with the federal court. It's basically a settlement agreement that will, in it, will have a statement of work of the design, all the design requirements and remedial action or construction requirements, as well as long-term monitoring and operation and maintenance of the systems. Negotiations have started. They started last August, and we are in that process right now. And so hopefully while we're doing the non-time critical removal action, determining what kind of treatment is best for the 1,4-dioxane, we will be able to basically start the remedial, we're starting the remedial design for the groundwater right now with this treatability study. So we'll be a lot ahead of the game in terms of the design for the groundwater. And the actual soil removal, it's like, as you want to call it, a dig and haul type situation. So that's that can happen over a pretty good short period of time. In terms of designing the vertical barrier around the holding basin, that's going to take probably a little more in terms of the design effort. But so we are hoping that we're going to be able to have a consent decree. That decree will be filed in federal court, and public comment period will take place. When that's done, you'll be notified of that as well. So I think basically what we want to do is we want to keep you folks informed about what we're doing. If you have any questions, certainly you can talk to any one of us. We have our contact information at the desk here as you walk out. We've done, Bruce and his team has done a lot of work all the way through since the site was essentially listed in 2001. So a lot of work has been done, so we are doing work. It's pretty extensive, actually, the amount of work that they've done so far. And we're trying to work, especially with the Acton Water District, in terms of providing them with information that we come up with, as well as they're sharing information with us as well. So, and this is what we have at the front desk for contact information. We also have the websites. This is Bruce's website, Bruce's company's website, and then also this is Bruce's website. This is EPA's website for the nuclear metal site. You should have all of the basically the important documents will be on that site: the remedial investigation, the feasibility study, the record of decision, fact sheets. This presentation will be on the sites, so you'll be able to see them again, and you can look through them. If you have any questions afterward, after you've taken a look at it, feel free to call if you have any questions on that. So at that point, I think I'm just going to turn it over to Sarah, and we're going to do a question and answer session. Wow, we're right in time. Oh, okay. Well, we should probably take this.
Yeah. Okay, if we're going to open up for about a 30-minute question and answer session, and because we're being recorded by the Acton Cable TV, I request that people take a stand at the mic at the podium so that your questions can be captured by the cable channel, and also so everyone can hear the question.
Okay. Let me answer.
I'm Pam Rockwell from Concord. I was wondering just how often you're going to be sampling for the 1,4-dioxane now that you're pumping to see whether it's working or not, whether you're going to be sampling the municipal well as well?
Yes is the answer. Right now, we're looking to do rounds of groundwater sampling every month for at least, I think, the first 3 or 4 months. And we've got ASBET 1A also in our list. So I'd actually have to look at our design. I'm sorry. Don't have it off the top of my head. But
so
yeah.
It's like in a month you'll take a sample and then we'll have some results?
Right now, we're sampling day 1, day 3, day 7, week 2,
Okay.
week 3. After we get through that first process, then we start the monthly process.
And
that's of the system influent and effluent. It's going to take several months, just even after we have the hydraulic containment going, before you would expect to see a change at the wells closest to the ASBET 1A well. But yes, that's part of the process, and that's what we're working with Acton Water District to do.
So is this process also going to pick up the TCE that's down in the water, and will it draw it into the river from the other side, from the contaminated side of the river?
Yeah. In terms of the river, the plume dives underneath the bottom of it. So,
for both the TCE and the 1,4-dioxane?
In this, there's green and pink, and there's only a couple of wells where we've actually measured TCE. Trichloroethylene, it's another volatile organic compound. The answer is yes. The TCE is less mobile in groundwater than 1,4-dioxane, but the plumes are superimposed. Our pumping will capture both. Our treatment system that we have right now, the temporary system, is actually better for removing TCE. The long-term system will be good for removing both.
Yeah, my name's Paul Garber. I actually live quite close to the site on the lower end of High Street. I hadn't been a relatively new resident, and I really admire your work. I mean, I think it's been good work, but, scientifically and trying to address the real problem. And my question is actually not any criticism of what you're doing, which I think looks very good. It's just my concern about the funding for the long-term remediation. Now, I didn't know much about the DOD and DOE funding, and I know that's one funding source that is different from EPA funding. But I understand this is a complicated business, and obviously we're all concerned because the 2018 federal budget calls for very sharp and deep cuts to EPA, including Superfunds, cleaning up Superfund sites. So I'm just asking, I know you can't really answer this authoritatively, but could you give us some ideas about how we might think about what it might take to make sure that we have the 20-year funding we need to actually do this job. Thank you.
Yeah, okay, well, first of all, EPA is not funding this. Okay. But in the consent decree, we will have financial assurances that will be agreed to, where if it's defaulted, there's language in there that we would take it over and treble damage, the costs to the responsible parties. However, we don't see that happening. You have to show proof of financial assurance prior to even starting, the job, right when the consent decree, before the consent decree is actually signed. So that's about as good as that gets. Most of the work is being funded by DOE and DOD. Yeah. I don't know what their budgets look like, but it actually comes from a judgment fund, it's called, where it's like a pool of money, just like we have a Superfund. It's a pool of money that money comes in and money goes out to do these cleanups. That's about all I can say right now. The respondents, the other two companies, they're paying a lot lesser amount for that.
Well, thank you very much. I just,
Sure.
Just as I say, that's a concern, and I had never seen this in print before. I mean, we have a lot about the technical parts about the site, and the website show all that. But to some of the considerations about funding, I think it would be helpful if we would have a little more written information about how this the prospects for funding this project over time.
Yeah, the prospects I don't think you're going to get in writing.
No.
If you go on the nmisite.org, the 3 existing administrative orders are there. The funding is, the requirements are there. And this site is unique in that we've basically required pre-funding. So when Elaine talks about the financial assurance, it's a trust fund at U.S. Bank of the full amount. And, if something was to fail, EPA can basically draw on that. I expect that for the remedial design, remedial action, it's going to be something similar. Because again, the biggest chunk of work is going to be the digging out. And we can't have trucks basically backed up and run out of money. And that's just not, that's a vision on how the right way to manage the project is. And it's, knock on wood, it's worked very well to the tune of about $90-some-odd million so far.
Okay, well, thank you. It's quite reassuring that there are alternate forms of funding than EPA, given the threats to the EPA.
That's true. Thank you very much.
Tara Fredericks from West Acton. I have a comment and then a bunch of questions. I hope you... Okay, great. So first of all, I'd like to just make a comment that what we're witnessing is the product of a practice where companies, that the public has to prove that something isn't safe, as opposed to corporations having to prove that something is safe before they start to use it. In Europe, we're told that's what they have to do. So just to keep that in mind, the bounding of the extent of the problem, again, I think we need to do that before we permit corporations to use these materials. The bounding of the extent of the problem, which I'm going to get to a follow-up question from Paul. Who's liable for all this?
98% of this is taxpayer money. So we are.
So the courts have supported the idea that the government, the federal government, will pick up the tab?
When the federal government is responsible for pollution, and this has been, you can go back in a lot of World War II manufacturing, and they do that through contracts, and that was the case here, then the federal government let the contract, they also carry some burden of the responsibility.
And that's been supported by the courts?
Yes.
To your knowledge? Okay. Dumping the toxins into the river. We live in the land of the 1% around here. So we're looking at effectively a town with white privilege that permitted with their application process, they signed the permits to allow this to happen, and now from that town, a lot of toxins are going down into the river. So as we march around in our rallies talking about environmental justice now and all that, I feel like this is a place where we can practice environmental justice, and I would like very much to understand the costs of not dumping it down the river and doing something else with it. Can we filter it? Can we process it? Is there something else we can do?
Well, are you talking about the 1,4-dioxane in groundwater?
I'm caring about anything that you won't drink yourself, sir, at dinner. So anything that's going into the river that we privileged people won't drink, why, what other options do we have besides putting it down into the river to go downstream to other people's water supplies in the ocean?
Well, Bruce,
Go right ahead.
we're discharging treated water to the Assabet. We are not treating 1,4-dioxane right at this moment. However, the 1,4-dioxane upstream and downstream have concentrations that are actually higher than what we're discharging. The numbers are in the single-digit part per billion. Not to say that that's, not high. It's obviously higher than what we've come to see as if you were to drink that water over a course of 70 years of your life, this, how we do a risk assessment. This interim time period, we don't feel like it's that a concern. What we are doing is we're actually trying to protect the water supply wells for the town of Acton, and that's why we're doing this groundwater remedy right now. Is we're trying to prevent this contamination from going into these wells.
And one other point, the treatability study that we mentioned to come up with a long-term treatment scheme, I'm looking at really two different modes of treatment. One is an oxidation technology, which is destructive, which basically doesn't have a waste stream other than treated water. The other one is a sorbent. You asked about, can you filter it? You can't filter 1,4-dioxane, but you can oxidize it with a mixture of ultraviolet light and sodium persulfate or hydrogen peroxide. You can also sorb it, and then you end up with a concentrated waste stream that you have to take somewhere else and incinerate. So, I mean, there's trade-offs. My preference is to do on-site destructive technologies and not have to truck it anywhere else. For 1,4-dioxane. For the uranium, we have, there's no treatment, there's no filtering when you have a few parts per million in hundreds of thousands of yards of site.
The next question, and I'm almost done. Where are the people who walked away from this? Is there a list of them? I'd like to find out if they got any money. So I would like a list of these people.
I don't have it. I
Is
don't work for them. They abandoned the site.
So, but you did know who they were when they gave you
I
the
knew
keys.
a worker who handed me the keys.
I see.
Not the owner, not the heads there. EPA, Office of Counsel may or may not be trying to pursue them, but it's not in my
Thank you.
span of control.
Is there any, how do I say this? A list of, I guess, the permit holders? We can go back. Because the reason I say this is that, there's this argument that corporations are people, and so therefore they should have rights. And so if they are in fact people, which I don't believe they are, but if those same people are
You're
arguing
welcome
that
to
they're
go
people,
to the
Then I'd like to go find
Massachusetts, I guess the Secretary of State,
Yeah.
and look up the owners and operators of Starmet.
Thank you. And the last question is sort of a two-part question. It's about what are we drinking now, and what other stuff is there? And I'll let you talk about that. Thank you.
Well, I think you should be drinking water that has, meets the criteria for drinking water, the maximum concentration levels for contaminants. And that would be the Acton Water District is the entity responsible for making sure that that water complies with the drinking water standards. I don't know if you, Matt or Chris, want to talk to that?
Speak from my seat. Sure. Matt Mosteller, Environmental Manager for the Acton Water District. Relative to the 1,4-dioxane, we have been sampling for that contaminant since 2006. Similar to what Bruce laid out, we have been evolving with the laboratory analytical and the health standards and health data. Our most recent round of sampling in treated water, which is the water going out to our customers, which I myself am drinking right here tonight, at the South Acton Water Treatment Plant, which is our only facility that currently has detections of 1,4-dioxane, was at 0.25 parts per billion. So that is below the state guidance level.
So I was actually interested in sort of some of the details because she was mentioning social justice. We're protecting the Acton wells, and right now we're not treating for 1,4-dioxane. You're dumping it right into the river untreated for 1,4-dioxane. And it's going down the river, and the Assabet River joins the Sudbury River and becomes the Concord River. And then in Billerica, people pump the water out of the river and drink it. So right now, when there's a whole lot of water going down the river, we're spoiled. Towards the end of the summer, we may well have everything that's coming down the river is something that's coming out of a wastewater treatment plant. And I understand that the river is already impacted for 1,4-dioxane. Is adding more to that something, will you be able to get this, your filtration and treatment up and running before we reach the low flows at the end of the summer? Or are we really talking December and maybe pushing that out a couple more years the way we've pushed out many other cleanups?
So right now, the remediation general permit, what EPA and the state says is acceptable to discharge to the river, if we were an industrial discharger, is 200 parts per billion. We're under 20, so we're a tenth of what is, call it, permittable. There's a significant amount of dilution as you move down the river towards Billerica, and I've been in personal contact with the water superintendent in Billerica, and they've been performing sampling upstream of their site, and they've been at non-detect. They see spikes in concentration above the roughly 0.25 that we see adjacent to our site. Their biggest hits just downstream of the Concord POTW.
And so you think by the end of 2017, though, that you're going to actually be able to meet
Yes.
the concentration that the record of decision says is
No.
0.46.
The two different things.
Right.
The 0.46 is the cleanup level. That's what we have to achieve in groundwater monitoring wells to say we're done. Mm-hmm. Discharge limit for discharge of treated water to the river is a different animal.
But it's created entirely by the EPA based on we don't really have information yet, and this is what the easy technology to clean up is, not on what's safe for people to actually drink down the river.
What we're doing is not an easy technology. What we're doing for the temporary system.
The 200 that is the limit on the river. You can discharge 200. Our cleanup level is 0.46, and the drinking water guidelines in Massachusetts are 0.3.
Yep.
So I would think we would want to aim for that 0.3 because you have a river that already has too much dioxane in it. Adding any more than the drinking water guidelines seems like a crime to me.
Yeah, we haven't set a discharge limit, but we plan on doing that. And it's going to be based on, partly on this treatability study on what they can get to. If you can't get to something lower than, say, even 0.3, then it's infeasible. However, That hasn't been worked out yet. We don't have a discharge limit yet, but we are going to develop one for the project.
And you think you're going to be on target to plan for that by the end of 2017 when you're putting in your permanent system to clean up groundwater?
Let me just go through sequencing. So
Okay.
we're starting about a 2-month treatability study, basically cost, performance, what can a 5 to 8 gallon per minute test system achieve. From that, we would scale up to a full-scale system where you have to build a new little building, procure that system, install it. We already have the wells in, we have the discharge system in. So we've already have a big jump start on it, and we don't see that being particularly complicated to get from treatability to 100% design to procurement and installation. When I go home to Connecticut, my public health department sets their guidance level at 3 parts per billion. So there's a difference in opinion about toxicological effects right now among different regulatory agencies. I agree with you. I mean, any is bad, right? So, this is certainly not a simple process to try to treat 1,4-dioxane. It's recalcitrant. It's difficult to remove. And that's why, with EPA's direction, we're going through a process to come up with the best technology. Somebody else asked about, where are you creating other waste streams? That's part of it. How much power does the system use? What are its other end products? Those are all variables. Cost. So for an unlimited budget, we could get it to none. I don't have an unlimited budget. So those are all factors, and we'll share, obviously, with crew, with Acton Water, Green Acton, what the results of this next round of studies go, and you'll see what we think we can achieve.
And this program is going to actually take out the other VOCs that are in this system too?
Yeah, those
so
are...
you'll have that all designed and ready to go hopefully next year?
The other VOCs are easy to remove, and they'll come out as easier than the 1,4-dioxane does.
And the site for removing them is the same site for removing the 1,4-dioxane, or are you going to have to put some wells
same well.
on the other side of the river as well?
We'll probably look at whether other wells on the other side of the river might speed the overall cleanup time, but the one that we have right now is the key one for cutting off the flux of 1,4-dioxane that's moving towards Assabet 1A, and that's really my priority.
And when will you have an idea of that you did that you cut off the flow?
I think we're going to start seeing results probably in 2 months. We should start seeing some decreases in concentrations at monitoring wells closest to Assabet 1A.
Okay, thank you.
And we can report that out, the analytical results, share with you.
Hi, Lori Gilpazaris from Concord, or West Concord, I believe, technically. I really have just a comment, although I'll share with you a question in my mind right now, and that is, yes, we're focusing on a few, toxic chemicals and trying to remove them, but how many of the chemicals out there and the byproducts out there have been tested for their effects on human health? So the problem is just, we're looking at the tip of the iceberg here, and we really don't have any idea about other chemicals. Now, I think it sounds great what you're doing, but I would like to point out that it's enormously expensive to take this approach. My background is in medical research and development of medical products, pharmaceuticals, and things of that nature. So I always bring with me a view of what companies have to do in the pharmaceutical realm or medical product realm to prove safety of any one product. And we don't come close to it when we talk about unleashing these toxic substances on the public, substances that we drink or breathe or whatever. So the same kind of routes of administration of pharmaceuticals. But that's an aside. What I really wanted to say is that over the last 4 years, I've been very involved and interested in bioremediation of the environment. And I don't hear that discussed in many places, but I am aware, and I wanted to share this with you. There was a person whose name I cannot think of right now. I'm coming back from 3 weeks of travel and haven't put it all together. But he developed a system for companies, and I know that it's been used on the Cape, and it consists of tanks of vegetation and different, are you familiar with this by any chance? I'm just wondering, why aren't we trying that? Because we have the unknown factor. We can follow and monitor and bring these things to different levels, but we may not be following all the things we need to follow. And it just seems to me that if we apply more than one approach, we will, in fact, have a safer environment. And as far as the social responsibility and environmental justice parts of this, we're still taking materials from here and we're shipping them off to Utah, to somebody else's backyard. And we all know that even though the standards for lining and whatever are presumably safe, that in fact they've been shown that they're not over time. There's leakage and breakage. And so anything we can do in terms of bioremediation on the spot is something I feel is very worthwhile looking into. Thank you.
Sure. Bioremediation is something that EPA is very interested in as well. We are trying to look at all kinds of alternatives to treat, to be more sustainable. Those are our goals as well. So if we can do treatment on site and destroy it, that's better than having to ship something off site. Sometimes it's just not feasible. A lot of it doing it with cost.
And the other side is, so 5-6 years ago, 1,4-dioxane was thought to not biodegrade at all. There's a big body of research right now showing that there are certain microbes that do biodegrade it. The problem with a system like what we're doing is trying to get to very low effluent or discharge limits. It's not as effective. Getting from 1,000 to 100 is easy. Getting down to 0.1 or 0.01 with biological systems is very difficult. And I guess one area, it's not bioremediation, but the approach we're using for in-situ treatment of the uranium is really, it's something that came out of the Hanford Reservation and other studies there. But what it's going to do is you can think of it as that it's going to precipitate the uranium as an insoluble mineral. So it'll still be in the ground. It's already in the ground at a few parts per million. But that's what this phosphate apatite does. It'll make trincavite or autunite, which is a very stable uranium mineral. And we've done some pilot study at the at the site as part of the FS with that. And that's vastly preferable to trying to pump the water out, filter out the uranium, and then, as you say, send that elsewhere. For the soils, there's just, and like their building materials, there just wasn't an alternative. There's no treatment for uranium in concrete, right? And so we did look at building, one of the options we looked at in the FS was build a big landfill on site, and that didn't get picked. Taking it to a certified place that's actually in Idaho was deemed preferable.
I forgot to mention the usefulness of plants, and as you say, there are organisms in the soil, in the air, that are capable of degrading a lot of these chemicals. But, should we be planting trees or plants, or should we be relying more on a combination of those?
Yeah, I've done phytoremediation using trees at one of my other projects. With this, with the plume being very deep, it wouldn't capture it, so to speak. So we have to pick the right approach for the right site, but we're certainly, advocates for things that work faster, cheaper, smarter.
Thank you. I'm going to turn to the next speaker, please.
Hi, my name is Barry Rosen, live in Acton. When you begin, or I guess you've begun, when you actually get to testing various types of remediation, are you going to do the testing serially, or are you going to do it in parallel?
We're doing it in serial. There's two of the technologies we looked at.
You're looking at UV?
Looking
oxidation?
UV oxidation with hydrogen peroxide as your oxidant is proven. We're running other systems. We know vendors that do that.
Yeah.
Synthetic media absorption is proven, running that, doing that. The one we actually want a pilot study that we don't have experience with is a UV activated persulfate.
Okay. But you're going to do these serially?
Yes. Well, actually, if the UV persulfate doesn't meet our expectations, we're probably
You're going to
just
fall back to one of the others?
Yeah, and our study is evaluating cost and performance in parallel. So we don't expect we would lose time. We just don't think UV peroxide needs a pilot study for our site.
And you've considered the turbidity of the water?
Oh, yes.
Already, you have?
Yep, iron removal, manganese, so forth.
Yeah.
That's all in the, yes, sir.
Okay. Who will, once we get a solution that's deemed a solution, who's going to operate and pay for the final remediation system?
Paying for is going to come out of the same parties that have been paying so far under the same agreement. Operating right now is through my company, or it's not, I'm a director of it for New England, but through
But
DeMax.
going forward, like
Yep.
50 years, who's paying the
Well,
bill?
right now, if you look right behind you, the guys in the back row are operating it. Turn around and wave. Okay, good. Yeah. And some of them are in their 20s, so.
Yeah. Is that, are they going to get paid by the Acton Water District or by somebody else?
No. There's a trust fund established that pays for
Continue the ongoing
studies,
operation.
design, and operations and maintenance.
Okay, and what is the goal of the remediation system? To get it down to how many parts per billion?
You mean for discharge? That's TBD. Plume cleanup is getting to 0.46.
Well, what I'm asking is, what are the straws of the Acton Water District going to pull up from the ground?
Yeah,
The
so,
raw water, what's that going to be?
so right now, I think you're 0.4 at.
Well,
estimate
it's
1A.
going up and down. I look at the Acton Water District numbers all the time.
By starting up this well, we cut off the conveyor belt, and then these concentrations out here will dissipate, as somebody else asked. I think within 2 months, we'll start to see declines here. And the goal, even if on this side we're still 5 ppb, the goal is that Assabet 1A, they clean up and they get to non-detect.
So when they suck up the raw water, is it going to be less than or equal to or greater than 0.3 parts per billion?
Less than.
Less than 0.3?
Yeah. The goal is to cut off.
And it will continue that way?
Yes. Basically, the hydrogeologic point is, as long as we're pumping over here at about 20 gallons a minute, we're cutting off think of it as the tongue of the plume that's been dragged over here, and then this severed portion will clean up. And we have to keep, as long as we're pumping here, the contamination will continue to come into our well. That's why one of our optimization ideas is, do we need to look on this side of the river to pump? That's a design issue.
Right. Okay, I won't take up
That's
more
fine.
time.
Happy to
Thank you.
talk more.
Thank you. Next speaker, please. And I think we're going to, after the,
Couple more.
after this.
Hi,
Speaker.
Ron Beck from Acton. Thanks for coming out here. We really appreciate it. I know people have been waiting for you to come out for a little while. So I guess public information is really good. This is actually a pretty good crowd for Acton and for the day before Memorial Day. So I think you can take from the number of people here that people are extremely interested in this. What I'd like to request, or hopefully get your commitment to, is when you do conclude or get fairly far along in your treatability study, it would be I think it would be really helpful if you came back and did another public information session to tell us, okay, what do you feel is going to be the treatment that's going to work?
Sure.
As well as sort of present to people in a way they can understand what the results of the monitoring are showing. I mean, I'm sort of knowledgeable in these areas, and you went through a lot of information really fast tonight, so hopefully it will be easy to get. So that would be great if you could come out again somewhere around that time. Second point related to that is, so I guess you have a website available for some of this information. What would be really helpful is if you could as you collect this monitoring data, if you could create a little online window there where people can see the results month by month as you present them, so.
Sure.
You know, because I think, as you said, 0 is good, and I think for the public, everybody has to make up their own mind if they feel like the results are acceptable to themselves and their family for the environment. I think that would be helpful. So I had another question, and I don't know, maybe you could help. I don't know the answer to this. I don't know enough about the regulations, the circular rules. So as I understand it, the Superfund site was initially designated for basically toxic materials that needed to be removed. And now you've discovered a groundwater problem, so is it officially designated as a site for groundwater remediation, or only for the removal of the uranium material?
No, you want to talk about listing?
Both. It was, groundwater was an issue even back during at the listing timeframe. So we just didn't know the extent of
So I mean, the question is, let's say 10 years from now, the plume reappeared because the modeling wasn't right or something, and despite all efforts, it came from a place you didn't know. Can you or the public go back and say, all right, Department of Defense, we need another plan because...
Yes, EPA, once a Superfund site, it's always a Superfund site, essentially, even if it's still listed. If there is a problem again, then EPA needs to go back and look at it and address it.
Okay, good. And final question would be, so when in this consent decree, you said you're looking at a 20-year remediation timeline, roughly. My question is on the monitoring part and the O&M part, what is the window you would look for in the consent decree? Because to me, let's say you viewed the life cycle of cleaning it up would be 20 years.
There's groundwater.
Yeah, so it would seem like it would be useful if you could get pre-funding for monitoring for some period beyond 20 years.
Yeah, one of the things is we're leaving radionuclides in place. There's a separate law.
Say again?
We're leaving radionuclides. There's going to be uranium left in situ.
Right.
So the Nuclear Regulatory Commission mandates if you're leaving stuff behind, your remedy is designed to last 1,000 years, and seriously at least 200. Because trying to.
So you're saying 200 is.
So when I've budgeted out like groundwater monitoring things, I've done a 200-year present worth. That's going to get factored into the funding.
Right.
So
all right.
yeah, we're looking well beyond 20 years.
Okay, good, thanks. Okay, so one other thing I was curious about. So you selected one well site to pump from. So are you sure that one well is enough to cover the whole thing? Because
no. It's where you start with, and you asked about this process and what if you're not sure.
Right.
If this isn't enough based on we're over here, based on the monitoring and we need more, we're going to go put in another well and plumb it in and start pumping it too. And that's already mandated in the order that we've signed.
all right, thanks a lot.
Thank you. I think the next two speakers can speak, and I think we're going to have to wrap it up.
I'll be
Thank you.
short. I'm Richard Kelleher, resident of Acton, formerly of Concord. And I have one question, that is the holding basin. You are putting down walls that are waterproof. I'm wondering what material, how do we think they're going to be waterproof for indefinite period?
Yeah, so there's a lot of these that have just been done to support the big dig. Right?
I worked on the big dig, so
Okay,
I know that.
so if you're
slurry walls, is that what you're talking about?
These could be soil bentonite slurry walls, they could be secant walls, they could be cement walls. That is a design issue. They don't have to be absolutely impermeable. The
And the slurry walls aren't, that's why we...
They never are. They never are. And that's why we have a serious pre-design step and then a design step. And for this holding basin remedy, the impermeable wall slows the flux of water, but this is really a belt and suspenders and maybe staples remedy. where we're going to do the apatite or the phosphate stabilization inside to essentially precipitate out the uranium. So if the wall's imperfect, we still have another mode of treatment.
Are you going to have monitoring wells just on the outside of it to see if anything's getting out?
I am 100% positive that neither EPA nor Mass DEP will not require wells. We're going to have, I'm sure, a
Yep.
fairly significant monitoring network.
Thank you.
Good question.
Hi, I'm Alan Fierce. I'm actually from Stowe, but I'm on the board of ORS, which is the watershed group for the Assabet, Concord, and Sudbury rivers. So I have some questions about the river, but I actually, just listening, had a couple of basic questions. I'm very glad you're trying to intercept this plume and protect the Acton drinking water well. But I didn't hear what you say the number is actually at the well right now, and I also didn't hear whether that well is still in use and being part of the Acton drinking water system.
The well's in use, and I think at our last sampling data, it's between 0.3 and 0.4 parts per billion, 0.3 to 0.4. And not to speak for Acton Water, but the water supply is a blended production. So there's a number of wells that are mixed, treated, and become the finished water, which is why Matt's able to say the finished water, what's going out in the municipal system is at
0.25.
0.025.
Yep.
Yeah.
0.25 parts per billion, and the action level or risk-based level that DEP has said is 0.3.
Correct.
So it's just the guideline, but it's a guideline that's determined by the Office of Research and Standards, which is a very prestigious group. I actually would put my money on ORS right now on this one instead of the EPA number. I know these EPA numbers and how they're set, and there's often a little bit of politics. They're often above the risk-based levels and guidelines that are set by ORS. And I'm just wondering why we couldn't have used that ORS number, Office of Research and Standards at DEP, instead of the 0.46. That number is 50% higher. It's 50% higher.
Actually, Gary, would you want to address that, please?
The 0.3 number is a guideline, which once you exceeded that, you would have to go through a process, and the process would be similar to what they went through instead of a risk-based number. If the 0.3 is not used because it's not enforceable, then this really should be on the mic, because people aren't.
Gary.
It's important.
Gary.
Sorry, the question was why wasn't the remediation goal set at 0.3 and it was set at 0.46? The reason is that the 0.3 is a guideline number. It is set because this is an emerging contaminant. It's a very conservative number that the water districts are using. Once you go over that number, which the Acton Water District has not been over the number, you would go through a series of steps. One step would be an ORS risk assessment, which would be similar to the process that EPA went through.
Couple quick questions about the river. You are currently discharging to the river. This system you said started up Tuesday?
Yes, sir.
Where is the pipe that is discharging to the river? And has there been signage posted so that paddlers know what that pipe is? ORS has instructed paddlers for many years to report to us discharge pipes that are discharging to the river. And I'm hoping that you've at least posted it, notified the paddlers. They may want to stay away from it, but I'd like to know where it is.
So if you are familiar with Knox Trail,
Yep.
and you're familiar with the former pump house for the gravel pit, which is right here,
Yep.
it's a little riprap basin right underneath the side, right underneath that pump house. And no, we haven't posted the river.
Could you please do that?
What would we say?
I'm not sure. But I do, but I do, but I think you ought to indicate that it's a water that is not being treated
and contains 1,4-dioxane.
It's being partially treated, but
We might need to post the river too. It also contains 1,4-dioxane.
Well, that's my next comment. Interesting. There is 1,4-dioxane in the river. And as you indicated, it is a product in a variety of products that come through the wastewater treatment plants. And there's a whole variety of them now. I call them PPCPs, which is an acronym for pharmaceuticals and personal care products. Many of them pass through people. Currently, EPA regulates the wastewater treatment plants and what needs to be treated or not treated at these plants. Currently, they are not asking the wastewater treatment plants to do anything at all about the PPCPs, including 1,4-dioxane. We've just been advised at ORS by EPA that the new wastewater treatment plant permits will be coming out this spring for 2 of the 4 wastewater treatment plants on the Assabet, another one in the fall, and one probably in the winter. My guess is that EPA is not going to set any limits for 1,4-dioxane or any of the other pharmaceuticals. And these are endocrine disruptors, and we're very concerned because of their impact on aquatic life. But as Pam indicated, people in Billerica are also drinking this water. I just think it's ironic that you're going to be looking to the level of 1,4-dioxane in the river as you assess what your ultimate discharge standard should be, when it is EPA which is determining what the level of 1,4-dioxane in the river can be through the wastewater treatment plants. I hope that all branches of EPA can come together and begin to ratchet down all of the PPCPs, but particularly this case, the 1,4-dioxane. And that as you go forward and set your standard at EPA, I think you ought to disregard completely the level of 1,4-dioxane that's currently in the river, since EPA has the ability to control that level. Will you set that aside in setting that final treatment standard?
I think the level in the river that we've mentioned is a sidelight. The current concentration in the river, if it was 0, if it was 3, I don't see it affecting our requirement to treat the water that we're extracting. That's a side note. We measured, I've reported, it happens to be there. I think our sampling from 2 weeks ago, we had a bunch of NDs in the river, so it varies. I will not touch what's happening in POTWs. It has nothing to do with, really our work on the site. I agree, but the fact that there's 0.21, 0.25 in the river is irrelevant to our need to effectively treat what we're extracting.
Final quick question. Will there be a public hearing like this when you design that treatment plan?
yeah, we can certainly have another meeting. We said we were going to have one. I think gentleman, Ron, requested to have a meeting after we determine what the final treatment system would look like for the groundwater, and we'd be happy to do that.
Okay. Should we take one more and brief question, and then we really have to wrap up. And Acton Water wanted to make some statements, comments also.
So Bruce, I thought I heard a commitment that your goal was to get the level of 1,4-dioxane that is pumped out of the ground at the Acton well to be at the limit of detection, which was like 0.15 on your chart. Is that right? That's the goal of this cleanup?
Well, I will only modify. We're going to address the NMI related 1,4-dioxane.
Yeah.
This order and our work does no effect on any other sources that may also be going to the well, right? I'm not aware of them, but yeah, I mean, our work is properly,
So you're looking for that limit of detection between your pumping well and
right.
the Acton well, and not what's actually coming out of the Acton well.
Right, and so this area here is where the NMI-related plume is right now. This area in here is where I expect to see concentrations, say, at these wells start to decline as this system starts going. You're not going to see changes over here for a while. But this side out here, and what's, remember, this well draws water from 360 degrees around it, not just from the NMI side of the plume. So what it's seeing is a blended or an averaged concentration. But as this area, as we cut off the flow, the concentrations in these wells should diminish, and that should result in lower concentrations in the extracted water.
Okay. Good luck.
All right. Thank you, everyone in the audience who asked questions. I hope that information was useful for everyone here. I'm just going to turn the mic over to Acton Water. They just want to share some information also.
Just to follow up to what I was saying earlier, we do have some information here with us tonight regarding our most recent groundwater concentrations or our finished water concentrations that will be available at the table. There's also a fact sheet from Mass DEP about 1,4-dioxane in drinking water included with that, as well as links to additional information and water quality data.
All right. Thank you, everyone, for coming to this meeting, and I'm going to call the meeting closed. Hopefully we'll work with the team on scheduling future meetings for the town of Acton. Thank you, and Concord.